This is Fluids, Day 2, Part 2. A person who weighs 720 newtons in air is lowered into a tank of water to about chin level. He sits in a harness of negligible mass suspended from a scale that reads his apparent weight. He now exhales as much air as possible and dunks his head under water, submerging his entire body. If his apparent weight while submerged is 34.3 newtons, find A, his volume, and B, his density. The person is at rest, so the net force on him is 0. So I can draw a free body diagram, maybe up here. There's the apparent weight, buoyant force, and the gravitational force, which we'll call W. So the person is at rest, so the net force on him is 0. So I can say his apparent weight plus the buoyant force minus the gravitational force is 0. Now I can substitute the buoyant force with the weight of water displaced. So that would be density of water times the volume of water times the acceleration due to gravity. So I can solve for the volume of the water, which is the same as the volume of the person because he's completely submerged. And that would be equal to person's weight minus his apparent weight divided by the density of water times the acceleration due to gravity. You can pause the video and take a little more time to do this if you wish. But now I'm going to substitute numbers in. His actual weight is 720 newtons. His apparent weight while fully submerged is 34.3 newtons. The density of water is 1,000 kilograms per cubic meter. And I have to multiply that by 9.8. And when I do this, I get 7.00 times 10 to the negative 2 cubic meters. That's part A. Now for part B of the problem, his weight is his mass times the acceleration due to gravity. And mass is the density of him times his volume and then I have to multiply by the acceleration due to gravity. And so I can solve for his density. I take his weight, divide by his volume, times the acceleration due to gravity. His weight, 720, His volume, we found, was 7.00 times 10 to the negative 2. And we have to multiply that by the acceleration due to gravity, 9.8. And when I put that in my calculator, I get 1,050 kilograms per cubic meter. And you can actually substitute in the units here, kilogram meter per second squared. And this would be meters cubed. And this is meters per second squared. So the meters per second squared cancel, and I get kilograms per meters cubed. A piece of wood with a density of 706 kilograms per cubic meters is tied with a string to the bottom of a water-filled tank. All right, I'd like to draw that here. So apparently this is filled with water. This is a pretty standard problem. And the wood is completely immersed. It has a volume of 8 times 10 to the negative 6 cubic meters. What is the tension in the string? If the string is cut, find the acceleration of the piece of wood. Well, in this case, I have two forces acting downward. I have the weight of the object, and obviously if the weight was enough to keep it down, it wouldn't float upward when we cut the string, so the tension of the string must also be down, and the buoyant force is upward. So we can say the buoyant force minus the weight of the object minus tension has to be, in this case, equal to 0. As we had before, the buoyant force, which is upward, minus the weight of the block minus tension has to be equal to 0. So I can solve for tension. Tension is equal to the buoyant force minus the weight of the object. The buoyant force is equal to the volume, or the weight of the liquid displaced. So that's rho v g minus the weight of the object. So that would be the mass of the object times the acceleration due to gravity. Now, furthermore, we can rewrite the mass of the object as the density of the object, which is wood, times the volume times the acceleration due to gravity. That's for the wood, or the object. And so we can find the tension. This is 1,000. It's completely submerged, so we said its volume was 8 times 10 to the negative 6th times 9.8. The density of the wood is 706. The volume, 8.00 times 10 to the negative 6th times 9.8. And when we pick up our calculator now, we find that the tension is 0.02305 newtons. Now, when we cut the string, then we have a net force upward that is equal to the tension. So we can find the acceleration of the wood. The mass of the wood is the density times the volume of the wood, and that is 706 times 8 times 10 to the negative 6th. And so the acceleration is simply the net force over the mass, net force being 0.02305 newtons, and the mass of wood so the acceleration ends up being 4.08 meters per second squared.